geometry students, in this video we will finally start studying volumes. Now today we're going to be looking at the volume of prisms and cylinders. So with that in mind, the heading then is pretty obvious. It's pretty obvious what the heading will be. So here it is. Go ahead and write this down. Volume of prisms and cylinders, lesson 12.4, and be sure and include today's date, okay? Volume of prisms and cylinders, lesson 12.4, and be sure and include today's date, alright? Very, very, very important. Volume of prisms and cylinders, lesson 12.4. Alright, now, in past lessons in this chapter, we have already looked at what prisms and cylinders are, so there's no need for me to give you a definition of a prism, or for that matter, of a cylinder, okay? So we're going to move on. There's no need to start there. However, before I get into formulas, there are some postulates that I think I should mention, even though I feel that they are common sense. Now, you will not be responsible for these on tests and quizzes, other than the fact that you will need to use them in problems if need be. So you should be familiar with these and know them, but you do not have to know them well enough to do fill in the blanks on the test. Here's one of those postulates I'm talking about, postulate 26. You can write this down if you want to, you don't have to, it's up to you, okay? If two polyhedrons are congruent, then they have the same volume. Now guys, I mean that's just common sense to me. If I have a rectangular prism like this, and then I have one just like it, well actually, I better do this, and I have one just like it, and they're congruent, then obviously they're going to have the same volume, okay? To me that's just common sense, it really is. So, if two polyhedrons are congruent, then they will have the same volume, okay? Alright, here's another postulate. You're welcome to write it down, but you don't have to. It's up to you, okay? But at least be familiar with this. To me, it's common sense. The volume of a solid is the sum of the, and this should be volumes right here, is the sum of the volumes of all of its non-overlapping parts. Now, whether you're writing that down or not writing it down, that's up to you, okay? But let me kind of show you what they're saying here by giving you a picture, okay? Now, I'm really bad at drawing, and you guys know that, okay? But I'm going to draw a really weird shape here, okay? But here's a real short cylinder, okay? Then on top of that, let's pretend we have a rectangular prism kind of sitting there. On top of it. That's amazing drawing skills. Anyways, you get the idea. You probably don't get the idea. That's really hilarious. But nonetheless, we're just going to pretend there's a big old block right there on top of it, okay? How's that? All this postulate is saying is if I asked you to find the volume of this whole thing, you would first find the volume of the cylinder, which is this right here, and then the volume of the rectangular prism up top, and then add the two together. That's all that it's saying, and to me, that's common sense, okay? If I asked you to find the volume of this, you would find the volume of each individual solid, and then add them together, okay? Now, I guess I should pause and do a little quick explanation as to what we're talking about when we say volume, and I really didn't have that in your notes here, but I'm going to go ahead and try to draw that up here real quick for you, okay? When I'm talking about volume, here's what I'm saying. You've heard something like 20 cubic inches or something. All that's saying is you could put into this box 20 guys that can draw. I just don't have that ability, okay? But, and some of you are saying, Mr. Eric, just stop while you're ahead, and I probably should. But anyways, if I told you the volume of this rectangular prism was 20 cubic inches, that means you could get, we're dealing with inches, right? So you could get 1-inch little cubes. 20 of those inside this figure. If we said 20 cubic feet, then that means you have a cube that's 1 foot by 1 foot by 1 foot, and you could put 20 of those into this rectangular prism up here. And that's what we mean when we say volume, okay? I hope that makes sense. Now, let's continue on. Now, I know I said back here that I wanted to mention some postulates that I thought were common sense. I knew one of them would be a theorem. I just didn't get that specific, but one of them's a theorem, and you're not responsible for this theorem, okay? So you can write it down or not write it down. It's totally up to you. But you're not responsible for this, as in terms of fill in the blanks. You are responsible for it, though, when it comes to understanding what it means, so you can use it in problems. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. That sounds a little confusing, and so I'm going to give you a picture here in a second, right now actually, that will hopefully make this theorem a little more understandable, okay? If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Now, cross-sectional area means this. If you could take somehow a piece of brown paper like this and run it through all of these solids, the area of this thing here and the area of this plane here and the area of this plane flat surface right here, if they all have the same area, and of course this, like an elevator, guys, picture this being a platform of an elevator, and it moves up and it moves down. If this four-sided quadrilateral here, as it moves up and down, does not change in size, it stays the same. And the same thing with this. As this four-sided quadrilateral moves up and down, it doesn't change size, it stays the same. That's what it means by cross-sectional area at every level, okay? That's what it's talking about. It's talking about this thing staying the same, this circle right here, as you go up and down. If, like an elevator, it doesn't change size, it stays the same. If that's the case, and the area of this quadrilateral is the same as the area of this quadrilateral, is the same as the area of this circle here, if that's true, then, and if the height of this is the same as this, is the same as this, then the volume of all three of these is going to be the same. That's not super easy to understand, but take some side notes. I've kind of lectured here for the past 2 or 3 minutes like a college teacher, not really telling you what to write down, but when you get to college, they're going to expect you to listen and to know what to write down, to pick out important things to write down. So just take some notes on this and make sure you understand that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume, okay? Alright, and hopefully this picture helps you a little bit. Now for the moment you guys have been waiting for, okay, with tons of excitement. So drum roll, please. And here we go. The formulas. So first of all, let's start off with the formula for the volume of a right prism, okay? So make note in your notes that we're going to look at the volume we're going to look at the formula for the volume of a prism, of a right prism, okay? A right prism. And of course a right prism, let's go back and look here. This would not be a right prism. See how this is slanted off to the side? This is not a right prism, okay? A right prism means that these lines here, these edges as a right cylinder. And that is not the case with these angles here. Okay? Here's the formula. Isn't that easy? Capital B means area of base. So area of base times the height. Area of base times the height. Well, you can write that down pretty quickly, so go ahead and do so. And then we're going to move on. Area of the base times the height. Now, let's apply this formula to a right prism. Okay? Let's apply this formula right here to a right prism. So here we go. In your notes, so that you don't have to draw this figure, I would put page 608, example 2. Page 608, example 2. Go ahead and copy that down. And then if you want to draw this picture, you can, but you don't have to. Alright? Now I want to say this. Please, students, please don't miss this. Okay? Watch this carefully. Let's say I rotated this thing so that it was sitting on how could we do this? So that it was sitting on, are y'all getting dizzy yet? Let's say I rotated this prism so that it was sitting on, well, I'm not going to have any luck with this, but when we're talking about the base of a right prism, please don't miss this. A base, it has to be a face that is congruent and parallel to the top face. Then and only then is your polyhedron set, or your right prism setting the right way. Do you see what I'm saying? Let me say it again. You must turn your polyhedron or your right prism in such a way that it is setting with the base or the face that is parallel and congruent to the top face. You must have a setting. So this is your base right here, okay? If you were to turn it another way so that it was setting on a different side, that side would not be your base. Let me say it for a third time. You must turn your right prism so that the bottom side is parallel and congruent to the top face. If you don't have a setting that way, then it's going to cause problems, okay? So to help you get a better picture of this, here's the front side right here. That's the front, okay? Now, with that in mind, if that's the front, then the top is right here. And the bottom is right here. And notice they're parallel and they are congruent, okay? So this is my base right here, okay? Now let's think this through. If this is 3, then this line right here is also 3. If this is 4, then this line right down here is 4. So look what you have, students. Your base, in order to find the volume of this prism, and please watch this carefully. I did not mean to do that. And that. My pen is really acting up again tonight. There we go. Alright, now, in order to find the volume of this right prism, you need area of base times the height. Now your base is a triangle. And look, guys, listen. This side here of your triangle forms a right angle with this side here. So if I were to draw this triangle off to the side, it would look something like this. Right angle. One side is what? 3 has a length of what? 3. And one side has a length of 4. Do you see it? And so to find the area of this base, it's 1/2 times the base times the height. So 1/2 times 4 times 3. That gives you 6. So 6 is the area of this triangle. So 6 is the area of this triangle. So the area of the base is 6. Now what's the height going to be? Well, the height is 2. So we have 6 times 2. So the answer is going to be 12 centimeters cubed, or cubic centimeters. Guys, find the area of the helps you to draw the base, the figure off to the side like I did here, to find the area, then do it. Pretend you're up in the air. Here comes some more drawing skills, so get ready. Okay, like you're flying here, okay? Put a cape on you. There we go. And you're up here looking down. You're looking down here with your eyes and you're seeing what this base would look like. It would look like this, a bird's eye view. Okay? Alright, that's finding the volume of a right prism. Here's the formula now for finding the volume of a right cylinder. Volume of a right cylinder, please copy this down. Pi r squared h. Pi r squared times h. And I'm really not, there's no need to give you what the variables stand for. By now you should know r is the radius, and by now you should know that h stands for the height. So pi r squared h is the formula for finding the volume of a right cylinder. Let's apply this formula to a right cylinder, and then we're done with our notes for today, okay? So here we go. In your notes I would write page 608, example number 2, alright? Page 608, example 2. And now here it is. Let's find the volume of this right cylinder. Now here we go. Volume equals pi r squared h. So for pi I'm going to put 3.14. For the radius I'm going to put 7 because the radius is right here. And for the height I'm going to put 5 because the height is right here. 5. Alright, so really, let me grab my calculator. We have 3.14 times 49, because 7 times 7 is 49, times 5, which would give you 769.3, 769.3 inches cubed. There we go. Okay, so guys, you know as well as I do, the homework, like usual, will be more difficult than this, but it gives you a foundation for what you need to do concerning your homework, okay? Volume of cylinders and volume of right cylinders and volume of right prisms, okay? If you have any questions, don't hesitate to call or email.